And yeah, the Microsoft Software and Systems Academy has career paths, but they're, whether it was network engineer, server administrator, database administrator, but they've gone towards more cloud computing and well, fundamentals and architect and administrator type level. Cloud has become their focus, but it seems cloud really melds in everything virtually that you would have in a data center, whether it's a storage or backup, security, networking. So those things, a foundation in all of those is important. And there's lots of technologies that allow you to make things work. And with how, how does packet flows, whether it's dynamic routing, whether it's virtually with Wi-Fi, like Wi-Fi version 6 has come out. Also something cutting edge, like artificial intelligence or machine learning. Those are up and coming areas where it's a specific type of next gen firewall. Peter, you got any other comments on that?
Not really. I think they just need to, different topics for their, whatever they're interested as far as network goes. So it's hard. I don't know. You kind of covered most of it, so I was not trying to think, and I can't really think of anything.
Well, guys, if you'll entertain one last thought on this, I had even thought about like doing a day in the life where you mentioned data center. Imagine having a day mapped out where a company determines that there's been a security threat. And then each of my group members might be assigned a portion of that as to what this person does, what the other person does, and then what steps are taken. And a day in the life would be the report, and of course the technologies that it touches in a way a company might respond in their network and organization to day-to-day operations. So I don't know if that's something that I can distill down into a simple report. I don't know, but that would be the other corner of that whole out of the box stuff I was talking about. And I don't know if that would qualify, whether or not we want folks to get that broad scope.
I do want to narrow it down on the specific technology that you dig into and do research about. Let's say you did some type of WAN technology like SD-WAN. It's a very up and coming technology. It's high performance with security. It has a lot of great benefits, and more people are using SD-WAN or quantum computing. It's up and coming way to do, can break encryption, can resolve issues that normal binary computers take years and years to create. Quantum computers can do in weeks or days, such as breaking down your DNA sequencing, or weather forecasting, weather patterns, very complex mathematical things or algorithms that can take many years. Encryption even can be broken quickly or completed quickly with quantum computing. Latest encryption standards. These are, one thing you could go actually is if you want to know something that people are doing research on. Where is my Zoom call? Let me share my screen. And screen 2.
Oh, Mark, before we get started, can I ask you real quick?
Yes.
So I saw somewhere that I'll have to do the subnet testing, and I took that test, but for some reason it's not there anymore. Is it a thing or?
No, I just removed it. I was That's the wrong one.
Okay.
So what I'm going to do is I'm going to create another IP test, and we're going to talk about IP version 4 now and into the next couple weeks, and then we'll take a test on that. But the first test will be more of a take home on the data center technologies we've talked about, and it'll be more of a, take it through this week type deal, and it's more of like a homework assignment. And so that'll cover the first couple weeks that we've been in class here. And so right now I've just hidden that basically from everyone.
Yeah, great. Thank you very much.
Yeah. So if you go to microsoft.com/research, people are seeing my screen, right?
Yep, we are.
Okay. When you go to research and you go our research, okay, these are the platforms that they are looking at. They're researching algorithms, the mathematics, data platforms and analytics, hardware and devices, programming languages, software engineering, quantum computing, security, privacy, and cryptography, systems and networking. So every one of these is an actual area where they have hired people to do research. And they're continuing to do research on these for new and better improvements in these areas. And so you can click on any of these. And let's say we clicked on systems and networking or something. And so within systems and networking, then it's going to come up and it's going to show you all the different research areas within this that they have people researching, authenticating drivers using automotive batteries, cost-effective cloud edge traffic engineering. Okay, that's an actual very interesting one where you have an edge network that has high speed response times, very low latency. Lightweight data race detection with pure thread memory protection. Some of these are very technical. Let's see, you've got, so you've got the ability to do, let's see. And well, each of these, well, there's 458 here, so there's a lot of them, and you can go through these and look at these. And this gives you some idea of things that they're researching. May give you ideas as well on, cost-effective traffic engineering or something. How do you shape traffic in a local area or wide area network or the internet? How you can specify, high, medium, low importance traffic. How do you manage the bandwidth that you currently have to make sure that you use it for the most important resources that they communicate? Improving latency, improving the utilization of that. So they've got publications that you can go in and look at that. Okay. So yeah, lots of different interesting things. And this is just microsoft.com/research/research. There's a lot of things that might give you an idea on some things to do. Other things I was just throwing together here real quick was so I was just writing some down as we were speaking to get an idea. Here's some here. These are just a list here. There's one here. So different technologies we could do: WiMAX versus Wi-Fi version 6, dynamic routing protocols. AI, machine learning, cloud computing, next-gen firewalls, voice over IP, latest encryption standards, quantum computing, latest WAN technologies like SD-WAN we talked about, cellular technologies like 5G. What's that going to do for us? There's some other very interesting technologies. I need to create a bigger list, but I like to have you guys kind of figure these things out on your own versus me just giving you something to, hey, do this. I want you more interested in find something yourself that you have a passion about. Okay. Okay. Let's talk about today. Any other questions with that regarding that?
No, sir. Thank you.
So we want to talk about IP subnetting. Now, many of us are familiar with this type of scenario where we have an IP address, and an IP version 4 address is an address that is in decimal form, 3 digits with periods in between these 4, what they call octets, first, second, third, and fourth octet. And why they are octets is because everything in computers breaks down to binary, and these are 8 binary bits in every one of these octets. So if you look at this, okay, this is what we really have when we have a decimal value. All right, and I want to do some whiteboarding here to talk about how this translates into binary, because that's very important to know when you're talking about networking, how this whole subnet creates the subnets and the actual IP addresses that are part of that subnet. And most people aren't aware of this. Some of you are maybe, and maybe some aren't. But it's good to review this because it's a critical element of networking, that knowing this, and it takes some time to learn. And so if we have something like this, okay, then here's a typical scenario. Now, what's in the middle is a router, and we have subnet 1 up above and subnet 2 below. Each device needs an address or an IP address, which is like a social security ID or like your home address. It allows data packets to find their way to you and for you to be able to communicate between point A and point B, whether it's from where you are to the internet or just to connect to a server resource and copy some files, whatever, to connect to a printer and print to that printer. And the gateway is what's called the default. Well, there's a default gateway, and the default gateway is actually the IP address of your router. And some people don't realize that. So you have an IP address, and you have a subnet mask, and you also have some other information that you were given when you get your address from a dynamic host control protocol server, which we talked about last Thursday. It gives you an IP address dynamically. So the next available one in the list within a scope. It gives you the subnet mask, which defines how many IP addresses are on that network. It gives you the gateway, which is the router IP address, so that you can know how to get out of your subnet and go out to the internet or some other subnet where you go to, where you have resources you need to access, printers, databases, internal websites, things like that. It also gives you primary and secondary DNS servers so that you can do name to IP address resolution. And it also gives you a lease period. And so that was talked about with Peter last Thursday, right? So if we config space / all, zoom it up a little bit. So here, the command was, oops. The command was that ipconfig space / all. It gives you all this information. So if you look at this, for my wireless LAN adapter, it's going to give you the actual adapter, the MAC address associated with that adapter, DHCP enabled, yes. Auto configuration enabled, yes. It's gonna, I have a link local IP address, FE80, but that is just so I can do a neighbor discovery and learn any neighbors with IP version 6, because I also have the IP version 6 stack running. Most, the best practice is to have both IP6 and 4 running, because they don't speak to each other. They're not compatible, surprisingly. Then I have my IP address here, my subnet mask, and I have how long my lease is for, and that's specified by the DHCP server. So in this case, I have a lease until Wednesday, 3 days. Default gateway is the IP address of the router. And then my DHCP server address, and then you notice these are all the same because I have a wireless access point at home, and that is doing, it's a multifunction device. It's the gateway, which is the router. It is the DHCP server, it's the DNS server, or it forwards it on to forwards it out to Comcast, right? So yeah. All right, all that information is given to you. And this information then is used to make a connection to point resource and communicate, pass packets back and forth. Well, the key element here is that you both have an address that's valid and that can be routed. And so we're going to talk about that. Okay. So, escape. It's driving me nuts. All right. Let me go to, okay, let me go to whiteboard here. And let's see, this is you. You've got your laptop. Okay. So your laptop has an IP address, and you are you're 1.5. Okay. You're the 1.5, and you have a mask of this. And typically you're connected, let's say you're connected to a switch, and then the switch connects to a router. And you have, over in the data center, you need to get access to your email. So router comes off of here, then there's a switch for this subnet, and then you have several servers. Let's say you have Microsoft Exchange, so you can get your email, and maybe there's a DHCP server over here that's going to give you your IP address and DNS to resolve name to IP. All right. Okay. So these are all over here in the data center. And this is maybe the student network or something. Okay. StudentNet over here. So you've got lots of different people out here. And this port right here on the router is the gateway. Okay, that's the gateway. So for people who are like, what is the gateway? It's literally the IP address of the router for your subnet. And so maybe this is going to be 151.155.1.1. Okay, and it can be any address. It can be the very highest address on this. Maybe it's a 254. Okay, but that is critical for you to talk outside of this subnet. All right, and over here, this port over here on the router is the gateway for the data center, and maybe that's a 151.155. Maybe this is the 2net, and this IP address here is 2.1. Okay, so on the 2net in the data center, the IP address there of the router, that's the gateway for these servers to get out. And when you're going in to get your email and you're making a connection, your IP has to go through your packet to get your email. First goes through the switch, through the router routes it. Okay, and this has, of course, has different ports. So from your port on the switch, it switches it, or it makes a virtual connection in circuitry between your port, maybe that's port 1 and this is port 12 or something, and it switches it here between these two. Then it goes to the router routes it from one subnet to another. Okay, and then it goes to the switch, and the switch then switches the traffic if you're going to exchange, and it goes there, and first it creates a TCP connection, and then it starts communicating with Exchange saying, hey, can display all of my email for me so I can get it. Okay, so if you're another IP address here and you didn't get a DHCP address from the DHCP server here, and Windows with IP version 4, if you don't get an IP address with Linux or Mac or whatever, you just don't get one. But there is a protocol called a PIPA in Windows that you can turn on or off in the registry, but it will give you an address here, a 169.254. 1.12 or whatever it does. It gives you an address here. Okay, and that, of course, it doesn't have a gateway. It doesn't know the gateway, which is the router address. Okay, so let's say the DHCP server was down, and these two got addresses, which is just generated from a specific range for Microsoft and their Windows product. And so that's 1.13. These two are not valid. They're valid and they can talk to each other. They can go to the switch and they can talk to each other, but they can't go out to the router, because when they go to the router to try and go to the internet or and try and resolve an IP address and go to the internet, the router says, that's not my address range. My address range is 151.155.1, where the 1net, and with this mask here, 255.0, it's 254 usable IP addresses. Okay, and so 169.254, that is not part of my subnet, so it's not going to route out. So you can't get out. The router literally just drops your packet. Okay, and so understanding that the gateway has been defined at the router, and the router is in charge of this subnet, helps you understand that if it's not defined at the router, then you can't get through the router out to and route to other subnets or out to the internet. So what we have is a couple things. One, let's take a look at some IP addresses here. Let's open up. There is a document that's called IP version 4 subnetting on Moodle. Okay. And in IP version 4 subnetting, in this notes document that you've got, it talks about, okay, different classes of networks. Class A, Class B, Class C, Class D. And these ranges for IP version 4 determine many things. One, this multicast with Class D is how you receive streaming media. That is your Netflix, you know, streamed video, audio. That's your Pandora, that's YouTube, whatever. And it uses this range, meaning the very first octet of your address, to the numbering within that 224 to 239. And so in our case, you've got Class A, which were the original ranges. Each of those had 16 million addresses, and companies and universities and so forth were given these ranges. So with this, when I put this 151.155 range, this is a Class B range, because you notice that the first octet starts between 128 and 191. Okay, so Class B, this first number here, 151, starts between 128 and 191. So it's a Class B. Okay, and when you get a Class B network assigned, and the IANA assigns these, that assigns companies and universities, groups, assigns IP ranges. Okay, so this particular range was assigned to a company called Novell, which I used to work for. That's why I remember it. That's one of the Class Bs. We had several Class B addresses, and there are no more IP addresses with with IP version 4 now, but companies have different ranges from acquisitions. So when Novell acquired a company called DRDOS, they acquired another range, a 137.65 range. That's also between 128 and 191, this first octet. And why is this an octet? Because when you break it down, it breaks down into 8 binary bits. And if you look at it in just binary, okay, instead of decimal, then this is the ones column in binary, right? For those, just quick refresher, the 2s, the 4s, the 8, 16, 32, 64, 128. So with 8 bits, that actually, when you add that all up, what does that add up to?
$255.
Yeah, when you add these all up, it adds up to 255. So that's the highest number any one of these can be in any one of these octets, right? So if I have a 13 here and a 4 here, okay, this is the here's my first octet, here's my second, here's my third, and here's my fourth octet. And it's an octet because oct means 8, and there's 8 binary bits that make up these, 3-digit up to 3-digit decimal. So this is decimal, right? The base 10 system. Okay, and so so what happens is with this we have the key elements up here, which was the gateway, the IP address, which is the address of each individual device, and we have a subnet mask. Okay, this is your subnet mask. And so we have gateway, mask, IP address, and then you're going to need, with DHCP, it's going to respond and give its IP address and the DNS address. And if this is the 2net, then this is like, 2.2, this is 2.3, maybe exchanges 2.1 or something. And maybe this is 2.254, okay, the gateway. But all those things are important to know so that you can communicate across the router. Now, how does this mask play into a router when it creates a subnet? Well, those masks you've seen, they look like this. They start out with, they look like this, okay? Here's class A, B, and C. Can everyone see this on my screen? Is that too small?
Yeah, we can see it just fine.
Okay. So if I have a class B address, that 150.155, the default mask is 255.255.0.0. And when I do that, that has one subnet, one big flat subnet of, this is class B. So class B is one flat network with 65,536 addresses. Okay. And because that's not wise to have just one flat network, for security reasons and for traffic, so what you do is you subnet it, you break it down into subnets or smaller networks or VLANs, subnets. These are synonymous, okay, for what we're talking about right here. And so with that, okay, you have this mask, and the mask determines, okay, then what subnets there are and how many IP addresses. Oops, what am I doing? All right, so 255.255, and we don't want just one subnet, we want many subnets. So what we do is, let's say we did this mask, 255.0. So this right here is the what's called the network portion. Okay, that's the network portion of the subnet mask. After that, we have this remaining 2 octets that we can work with to modify. We can't change the 255.255 with the mask because it's a class B, Well, we can change that third and fourth octets to modify that to have subnets and how many IP addresses per subnet. In this case, we're going to divvy it up into the third octet being the subnet. Okay. So that's the subnets. And then this here is the nodes or hosts. Okay. This is the IP addresses per subnet. And what that means is we know that the maximum amount in each of these is from 0 to 255. Now in computers, 0 is a number. So really that's a number which we would count as 1 plus 255, because if you add up all those ones, it's 255. But it could be all zeros, and that could be a number 2, which is 0, right? That equals a maximum of 256 as the IP addresses within this, when this is all zeros, when this is 0 here. Okay. Now, in binary, we're going to break this out and show you how you can change it all. But for now, we see that we got 256 addresses. The 0 in this case equals the, this is the address, the network ID, okay? This is the network ID. And the 255 is equal to the network broadcast, okay? And so you can't use those IP addresses. You cannot use 0 in this case, and you cannot use 255 because 255 cannot be assigned to, say, a server or a laptop or something, because 255 is the term for broadcast. When you send it to 255, it sends the packet to everyone on your subnet, including the router. And when you don't know who to send it to, when you just open up your laptop and it has no IP address yet, it sends it to the all broadcast, which is 255, 255, 255, 255, right? All 255s. And then that sends a broadcast out to say, hey, I need an address, like what Peter talked about, okay? Which is, it'll go to your, up here in our network diagram, it will go to the router. Now the router normally blocks that broadcast, all broadcasts there. So a broadcast domain is just subnet 1 and subnet 2 here. It keeps them within those subnets. But special broadcasts it will pass on, including one for DHCP. The DHCP discover will get sent unicast over to the DHCP server. It will respond and give you an IP address, DNS, mask, gateway, and all those elements of your lease. And then you will respond back, and you will accept that, okay? And it's DHCP, let's see, discover, offer, response, request, and then acknowledgement. Did you go over that, Peter, Thursday?
Yes, we went over it.
Okay. So now you get all that information back, and this is what we've got, and it gives us this. 0 defines for the router, the network ID defines this network in its tables, in its routing tables. 255 is the broadcast when you need to use that for some type of broadcast packet. And so the other remaining IP addresses on that are the usable. So it's 2 to the n is the formula, minus 2, which is the 0 and the 255 in this case, equals usable host or node IP addresses, okay? And so in this case, we have 200 and a total of 256, right? And because this subnets there's 255, or technically 256 because 0 is a subnet, that you're saying, okay, when it's a class B, you got 65,000 IP addresses. Well, when you have 256 subnets times 256 IP addresses, that equals 65,536. So see that number, 65,536? What we did with this subnet mask is we took, instead of being one flat network, we said, you know what? I want, here's my default network portion, and I'm going to have 256, because 0 can be a subnet, 256 subnets, and 0, this could be 0 to 255, and 0 is counted for nodes. So that's why timed 256 times 256 gave us 65,535. So all of those nodes that are possible with a class B address, when it starts out between 128 and 191, can then be subdivided with the mask to whatever you want as the network engineer. So if someone is a network engineer and they say, I've got this big range of 65,000 IP addresses, and I want to break it out into several networks, that's what your subnet mask does. It does the division. And the second that I put on this gateway up here, when I put on the router, I put a router IP address, and it says on the interface for this interface 0 or something, and or 0/0 or whatever, and this is 0/1 or whatever. It says IP address, and it gives the address 151.155.1.254 space, and then I give a mask 255.255.255.0. The router then calculates and says, oh, okay, I understand what you're doing. This, our subnet here on the left, the subnet 1 is 151.155.1 from 0 through 255. And it knows that there's only that many addresses. Now, if I change this, this is where it gets complicated, is let's say I change this to, all right, I'm going to erase some stuff here. All right, so now I've got, I'm gonna switch this out. And so you had the 8 plus 1, 2, 3, 4, 5, 6, 7, 8. And now this one is 1, 2, 3, 4, 5, 6, 7, 8. And this last one was 0. If I put it in binary, it's 1, 2, 3, 4, 5, 6, 7, 8. It's binary, okay? So that was 0 here. In decimal, it's just 1 0. But in binary, it's 8 bits. So I have to have 8 zeros. And that's where the line is, right there for my mask. Because the mask was 255.255.255.0. That's what it looks like in binary. But let's say I changed this, okay? I changed this now. And I changed this to, I put this red line right here, okay? And a mask is basically all the 1 bits. Once those 1 bits stop and it starts to become zeros, okay, then that's where the nodes start. So this was a 0, oh, sorry. I'm going to do blue. This was a 1, and now I'm going to change it to a 0. So forget the periods in here, because your computer really doesn't look at the periods. It just looks at the ones in this number in binary, and it sees it as all ones. And when it stops, of course, this was the network portion over here, right? That's a network portion. Okay, and so this is the network, right? Network portion of the mask. Here now is my subnets, and here now is my nodes. Okay, now, so what we did is we moved it over 1, 2, 3, 4, 5, 6, 7, 8, but now we added one more 0 and made it 9. Okay, and here, which was 8 in this third octet, 1, 2, 3, 4, 5, 6, 7 now instead of 8. Those ones are the subnets. So now my subnets are, this is of course binary, 2 to the power of 7 is going to equal my subnets. And if I use this formula over here, 2 to the n minus 2 for usable host IP addresses, then I say 2 to the 9, right? 2 to the 9, because I have 9 now, minus 2 is usable host IP addresses. Okay, and so what are these usable IP addresses, and what are the subnets now? Who can do that quick math for me?
So 128 for the subnet and 510 for the host IP.
So these are 510. So 512, but minus 2, 510 usable. And subnets is 128. Now it was, before this, it was 256. Now it's 128. Okay. But if I take that with my calculator, I now have 128 subnets, and each one has twice the IP addresses as before. So if I take if I take 500, well, the total, 512 IP addresses total times 128 subnets equals, again, 65,536 addresses. So I'm not losing any addresses here. You'll notice I still have 65,536 with my class B address. Okay, but what I have is I now have 128 subnets with 510 usable IP addresses. Okay, so I'm losing 2 IP addresses as far as usable on every subnet when I do this, but the total remains. You see how I'm not losing any of the 65,000. I'm just subdividing it, and I have 128 subnets with 510 usable. And how do I do that now? So what happens is, and this is confusing, is that if I started out with my 0 net, and that was equal to 256, and then my 1 net, these were my networks, okay, or subnets, that was equal to 256. My 2 net, that's equal to 256, and so forth. What I did is I combined these two together. Okay. And so when I combine those two together, that makes 512, or 510 usable, because the 0 on the 0 net is the network ID, and the 255 on the 1 net, the highest number, so 1.255 is my broadcast now. So I've combined 2 networks into one, or 2 class C networks into one. All right. And a class C, a quick reminder, is just 256 addresses. And that's from the range of that first octet of 192 to 223. And so you have a maximum of 256 addresses. And so that's all that a class C starts with a default mask of 255.255.255.0. And so when I have a class B, which is what I'm using here, I can subdivide it lots of different ways. And my mask, where I originally had, it was like a class C default mask, but with a class B, I can have any combination of third and fourth octet with my mask to configure it however I want to make, well, within a specific parameters, to create the amount of subnets and the amount of nodes per subnet. So really, technically, up here, I had the 1net and the 2net, but really, let's say it was the 2net and the 3net. That's actually more correct. If I did the 3net here, that's also, 256. And so those two combined together could be 512 or 510 usable. Okay. And so if that's the case, then if I go back up here and I have this gateway as, let's say this is the 2 and the 3net. So this is actually 3 over here. Okay. This is 3 and this is 3. Okay. 150, 155, 3. Okay. And then I put my mask on there of 255.255.254.0. And how I got that was before those 8 bits added up to 255. But now they're not 8 bits anymore. It's actually 7 ones and a 0. Okay, because really the period is, the dot actually is right here. Okay, so it's 7 ones and a 0, and that's 128 plus 64 plus 32. So when you add them all up, it's 255 minus 1. So this becomes 254. So that's my mask. And when I put a 254 up here, and I say 254.0, okay, the router says, oh, okay, that's what you want to do. You want to have 510 usable 3.1. You want to have 510 usable, so I will use the 2net, and it's actually 2net and the 3net. And because I had already set up my 2net over here for the data center, this actually encompasses 2 and 3. Okay, so it actually says, hey, you're overlapping. You can't do this. So maybe I make my, this be the 1net over here, 1.254. And this over here be the 2, this is the 2 and the 3net over here, and that gives me 510. So those 2 nets combined together, it's like 2 class C's being combined together, gives me 510 usable. Okay, so we're kind of going quickly over this. Is this confusing or is this enlightening? Does anybody have any questions?
I think for me, Mark, it it makes sense at the time I'm seeing it, and when you assign the values and we can see the range. My worry is 7 days from now. You're right. I got to find a methodology that helps lock down how the subnet is separate from that network portion. Otherwise, I think it's good. I just have to go back and keep looking over the differences in those octets. So
Yeah. So we're going to keep going over this. But what we've got is the mask is the key to defining how many subnets you have and how many IP addresses per subnet. And that is what we call variable length subnet masking, or VLSM, okay? And you can have some subnets that are 1024, because if you added these all together, if you added these 512 and 512, you got 1024. And if you need 1024 addresses, you have to combine all four of those: the 0, the 1, the 2, and the 3 net. And how do you do that? Well, you literally have to take away one more 1 here, and you've got to make another 0 here, and 1, 2, 3, 4, 5, 6, 7, 8, and now you draw that line where the 1s stop right here, and now it's 2 to the 6, because there's only 6 1s left in the third octet, so there's only 64 subnets. Okay, 64 subnets. But over here, you now have 10 zeros. Okay, 2 to the power of 10, all right, is 500, and or 1024 minus 2 is 1022 usable IP addresses. And so now you have used ranges 0, 1, 2, and 3 to have an IP that's within all 3 of those is valid on the router interface to go that subnet with that mask. And the mask now changes, okay, because I had to take another 0 out in the third octet, which is equal to the 2's column. So that's 255 minus 3. Now it's 252.0, okay? And so now when I have a router down here, and my router says 151.155.0.1, okay? And these are binary bits again, so the mask can be this, 255.255.252.0, okay? And that, what we see, that gives us 1024 addresses. It uses 0, 1, 2, and 3, okay? There's only 64 subnets now with 1024 each with a class B. And this, so we can do that. Now, this first one over here, or each of these is, each of these is 8 bits. And so we see that this is 8 right here. I'll do it here. 8 plus 8 plus, in this case, there's only 6 more, it's only 6 more bits in the third octet. And that gives me 22 bits. So if you've ever seen where you do a /22, that's what they're talking about. It's all the ones added up, make up, this is called Cider notation. So this Cider /22 is the same thing as that written out decimal mask up above 255, 255, 252.0. So a /22 or a 252 mask, those two are the same. Okay. And this is the router here. Okay. So when you do that though, the router calculates and says, oh, you have a /22 or 252.0 mask. Okay. Well, then that's 1,024 total addresses, 1,022 routable, and there is an executable or an installation or MSI file for BitCricket. And you can install this on your laptop and use this too. It's a pretty, it's very well done. So I'd say I'm the 0net here. And I go to Subnets. And I go to a /22. Okay. All right. Now, if we look at this, we see that it knows there is, it's a class B subnet. It knows that the network portion of the subnet is these N's for network, the first two octets. Then it knows the next 6 bits, those ones are part of the subnet portion of the subnet mask. So there's a network portion of the subnet mask, there's a subnet portion, and then there's a host or nodes portion. That's the H's right here. And those H's are the 10 bits. So host bits 10, max host usable 1,024, okay. Subnets 64, and subnet bits 6, which is what we saw behind us on the whiteboard. And if you look at this, then it's broken it out into 64 subnets. Subnet 0 is first with 151.155.0.0 starting out, which is the subnet ID. Usable host addresses are 0.1 through 3.254. And then the broadcast is the very highest only. 3.255 is the broadcast now. So 2.255 or 1.255 or 0.255, those are not broadcast addresses. Those are actually valid addresses within this group. Okay, and it's taking 4 class C addresses, 256 times 4 gives you 1,024. So it's combining them together. Subnets 0, 1, 2, and 3. And the next range, if my IP address was 5.3, okay, then you see how it jumps down here, where my IP address is in here from the 4.1 through 7.254 usable. So again, 4, 5, 6, 7, that's 4 ranges of 256 each, makes 1,024. The subnet ID for the router to identify that network on the router in the network is 4.0. That's the lowest IP address. And the very highest, 7.255, is the broadcast. And that would be what once you get an IP address and you send a broadcast out, like an ICMP, like an ARP broadcast or something, to say, hey, with everybody else's IP addresses and MAC addresses on my subnet, you send an ARP broadcast to 7.255, and everybody responds and gives you that information, so that you know who all your neighbors are and that information, so you can talk to them just directly with the switch there, or with an IP address. Anyway, so yes, this is how this is subdivided up. The subnet mask subdivides into subnets and hosts, and these hosts change. You can notice that there's some very similar numbers. These are usable addresses, so just add 2. So 8192, 4096, 2048, 1024, 512, 256, 128, 64. Of course, these are usable hosts, but look at the subnets. You see how these numbers parallel? 248, 1632, 64, 128, 256, 512, 1024, 2048, 4096. These and these are inversely proportional, okay, or relational. So that's something to remember. You can only have subnets with these certain IP addresses. Sorry, subnet, that's the amount of subnets, and then the amount of hosts, available IP addresses, are only these, which is basically the other number -2 for the subnet ID and subnet broadcast. But these are the same numbers here, all right? And so you see them, always is that difference.
Mark had a quick question to make sure I've locked this down. With the Cider, the CIDR notation, even though on this picture here with the BitCricket, that /22 has nothing to do with like the max host 1022. That's count, like you were showing, it was showing the octet binary. So that's actually a count of all of the ones in the first 3 octets.
Yeah.
Okay.
So that
okay.
Cider notation is counting all the ones in the subnet mask. That's where you get it.
Gotcha.
And don't click on BitCricket because it's not functional anymore. They were acquired or something and no longer exist. But anyway, okay. So yeah. So in this, if you click in this area, it tries to go to bitcricket.com, but no longer exists. So anyways, yes. So those, in this case, it's a Cider notation, and it's just counting all the bits, which is, in this case, it's 22 bits. And then the rest are open, which means that's nodes, right? And so Cider or subnets. But you also see that it puts in the Cider notation too, /22, /23, /24. You know, a standard class C address with a /24 Cider notation is a 255.255.255.0. And that's, 256 subnets, 254 maximum hosts. And you see it broken down here. Here's all your subnets right here on below, right? So it's very simple. People are usually familiar with subnet ID of 0 and subnet broadcast of just the top of that. Like if it's a 1net, it's 1 to 55. But as you saw, it can be a completely different subnet number .255 for the broadcast. And as you go farther into class, making them bigger than class C, that's called supernets, where you're combining class C subnets together, and that's supernetting. And if you go smaller than that, you can go smaller than this, you can do it's stubnetting. All right, being smaller than 256. That's what they call it. Okay, so maybe this is a good stopping point. We're starting to run out of time here. Any questions on what we just talked about?
I have only a minor one, but I don't want to make it counterintuitive just talking about IPs and subnetting. When you're looking in your diagram, you use the example of a switch. And I know that a lot of networks are constructed with what was originally called like hubs and smart switches and so on. Is it my understanding that a switch, when in its normal representation, is smart, and some of the switches, like a router, are going to keep track of these assigned IPs and then focus communication directly between them as opposed to stair stepping or being passive in the way that they transmit and receive?
Well, these switches here are at layer 2.
Right.
And layer 2 just uses the MAC address to actually transfer. So they look in the header of the packet or the frame, and they look at the MAC address, and that's how they switch it. So they don't even look at the IP address, okay? They're at layer 2, but the router is at layer 3, and that looks at the IP address to route it where it's going to go.
Okay.
And a switch technically doesn't even need an IP address on it. The only reason you have an IP address is so you can remotely manage it and configure it and get performance statistics. But it's more of just a management IP address, because the switch just works at layer 2 with MAC addresses, and it has a MAC table. But this address resolution protocol MAC to IP address is at the router. It's also at the, it's over here. You know, you've got an address resolution protocol here, and you got it on your laptop here. And that's breaking down, you know, MAC address to IP address. And so when you want to just communicate right here, okay, you can create a frame with the MAC address, and the switch will just switch it to that port, and it'll go through the switch.
Right.
But when it's an IP address, you've got to have a complete packet with IPs, source and destination, which you know it's not on your current network. And so you send it to the router, and the switch, not having that MAC address where it's going to, sends it to the router. The router then looks up its address resolution from MAC to IP address, and can also send it on its way to whatever destination it is. And then the switch then looks at the final MAC address. But again, these switches use MAC addresses. The router uses IP addresses, and there can be multiple routers, of course, in going to your final destination and back. Right, that route to some type of internet website. Well, it goes through many routers, right?
It does.
So again, that if you look at if I did trace RT, like trace route to, let's say, Amazon.com, it goes out my router, which that's an ASUS router. And now it's going out, it's going to go and find every router is a hop along the way. It's going to go to Comcast, looks like Tumwater is where you've got a rural router for Comcast. There, you see that, 213, 218. Now we're going to Seattle. Now it's jumping to 22. That's in Seattle. And now you've got a core router, the internet backbone. So seattle.wa.ibone.comcast goes there. Then it's routed to this other one. Some of these have, when it resolves, most of these are for, look at this, Mile High, is that in Colorado? Comcast has a data center in Denver, and I did a data center design with Comcast, helped them improve their data center back when I was with Intel. But then where's it go? It's going down to Texas here. And I'm assuming, I'm taking a guess here, Stemmons, Texas, Internet Backbone, Comcast.net. And where is it going to hit Amazon? Well, it gets to 16 and 16 hops. Let's see, that one timed out. But these are all the routers. When I'm going to, I was thinking it was closer. I thought it was in Oregon. I thought Amazon was in Oregon. But anyway, I didn't say actually, I didn't say AWS, Amazon Web Services.amazon.com. So Amazon, the actual site where they sell the books or whatever it resolved to, it resolved that 54.239.28.85. And it's trying to then see every hop in the process to get there. And every one of those is a hop in a dynamic route that I would take to get to that final address, 28.85 there. Okay. And so all those routers are routing. Some are going to resolve, some are timing out here. Anyway, gives you an idea how many routers it can go through. There's hundreds and hundreds of routers on the internet all over. So, okay.
Hey Mark, if you're using VPN, will that going to reflect on here too?
Yeah, well, VPN is going to have it's going to, I wonder if it would hide all those in between. But it has, from point A to point B with your link, it's a tunnel. And would that tunnel pick up all of those? That's a good question. Peter, do you know?
I bet not. I don't know for sure, but I bet it just kind of skips it all. And then if you do a trace route, it jumps from wherever you're VPNing to.
To the end destination.
Yeah, because I think it's unencrypted. The trace route program is.
Yeah. So yeah. Okay. Well, let's start. Let's stop there, and that gives you a first little taste of this, and then we'll start talking about subnetting, going smaller than 256. I went a little bit bigger than 256 today, but we'll continue on Thursday talking about this. So hopefully then at some point here, you're going to really pick it up. You're going to know it, and we're going to do a workshop or a homework assignment on how you would subnet a bunch of different sales offices, and we'll work through that. Okay. Right.
Hey Mark, I got one more question on that subnetting.
Yeah.
It's a little out of context, but for IPv6, will it going to be just same theory but using a hextet, or will it be different calculation for it?
So IPv6, it's in hexadecimal instead of octets. They're double octets. They're 4-digit hex numbers, and there's 8 groupings instead of 4. It's a 128-bit number, but same type of deal. Routing is done with an IP address, source and destination, and the subnet mask is actually built into the address. But we can talk about that. But it's basically the same process.
I see. So for the calculation part, how many hosts and how many subnet we're going to have, will going to be included in the IPv6 inside of it. Oh,
The
okay.
subnet is
Yeah.
part of the IP address, but the big difference with IPv6 is that when I change the subnet mask, it doesn't change the number of hosts per subnet. That's a new change in IP version 6. And when we talk about that, you'll see why. It's always the final 64 bits is the node or the host portion of
I
that
see.
address. Yeah.
Great, thank you.
So it's 18 quintillion IP addresses for every subnet. Yeah.
That's a lot, right?
That's a lot, yeah.
Yeah.
Billion. Yeah. Okay. All right. We will see you all Thursday.
Yeah, thank you, Mark.
We can stay on
Good.
here as long as you need if there's other questions, but we can drop off. So
No, good deal.
thanks, everyone.
Thank you.
Hey Mark, I
Yeah.
just try with the VPN by for the trusted.
Trace route, trace
Yeah,
hierarchy.
trace route. Yeah.
Did it come up with just the beginning and end point?
Yeah, the first point has changed from my private IP or private IP 192.168, but when I use VPN, it start with 10.14, and then the second route also a bit different.
Yep, that makes sense.
Yeah.
What's the next one? Oh, it's the IP address has been given to you to create the tunnel then, huh?
Yes. Looks like it.
Yeah. So all of that is basically is hidden from you, hidden from that trace route.
Yeah, it looks like it because it doesn't contain or pertain any of my information inside of it. When I tried it with my own IP address, it's starting from my private down to the router and to the public IP. But here with the VPN, just totally different random numbers.
Yeah.
Great. Okay. Thank you very much.